All right, guys, here we go. I told you I was going to go through each type of equation, and I was going to help you understand what the process is. The process is the most important thing, right? It's not the answer that's the big thing. It's the process, right? How many teachers have told you that in your life? And really and truly, it is our goal as educators to get you to understand the process, because no, you're not going to be walking down the street and someone going to walk up to you and say, hey, what's 3x equals 6? No, but you're going to have to go to work in the future, and you're going to have to solve problems. And to solve a problem, you have to analyze what the problem is. You have to look at the problem, understand where you need to go, and find a way to get from one end to the other end. And that's why we solve algebraic equations. That's why we increase the difficulty of solving equations, because we want to teach you to get used to a step-by-step process to get from point A to point B. We want you to succeed in life. That's why we became teachers. Well, we became teachers because we wanted to torture children, but it's more fun to say, hey, we want you to be able to solve this, because using that type of skill of analyzation is going to help you in the future, in your life. Okay? It's a life skill, believe it or not. Seems completely unreasonable that algebraic equations are a life skill, but believe it or not, they are. So the rule here is we want to isolate the variable. We want to end up with one lonely little x on one side of the equal sign, so that we have one value on the other side of the equal sign. Should be very simple. And all we have to do with this single step equation is look at what's happening to the variable and undo it. That's a short, simple way of saying, hey, is there something happening here that I need to undo to get x all by itself? And we understand that equations are balanced, right? It means that this side is exactly the same as this side. 3x is exactly the same as 6. Well, if you take off some weight on that side, but you don't take off any weight on that side, our barbell falls over, or our scale loses balance, right? So we look at what's happening to the x here, and any number in front of a variable means multiplication. And I think you guys already know that. And so we have to do the opposite. We have to undo what that is, so that we can go ahead and find the value of one single x, right? So how do we undo, or what do we do to do the opposite of multiplication? How do we undo multiplication? We undo it with division. Now, I like to rewrite the whole thing for a single step equation, and then do the math on top of it, because I like to see what I started with. I like to show the math in the next step, and then I'll have my final solution in the last step. Now, I don't necessarily have to rewrite this one, but I will, just because I am an annoying teacher. All right, so I want to undo my multiplication with division, and in algebraic equations, we use the fraction bar, because fraction bars mean division. That's what this symbolizes. That means it's a fraction, right? This divided by that. I don't know if you knew that in the first place. That's why we wrote a division symbol like that. It just means it's a fraction. All right, so if x is being multiplied by 3, I just simply divide by 3. But if I divide by 3 over here, I have to do it over here, or else my scale is going to be out of whack. So I do the same thing over there. I like to put that 1 right there because it shows me that 3 divided by 3, any number divided by itself, is 1, right? If I had 3 marbles and I wanted to put them into sets of 3, that's great. I have 1 full set of marbles. I don't know if that makes any sense to you or whether you care, but now that I have 1, I bring it down here, and then I divide 6 by 3, and I simply have 2. Right? Hopefully they're that easy. If it's not that easy, that's what calculators are for. Right? You just remember to put in 6 divided by 3, and now you have 2. The second one is just as simple. I say, hey, what's happening to x right here? What's being tagged on the back of it? Is there anything being added or subtracted to it? Are we multiplying it or dividing it by a certain number? And for our purposes, the only thing that's happening right now is we're subtracting 8 from it. All right, well, how do I undo that subtraction? And we just undo that subtraction with its opposite. So we're going to add 8, so minus 8 plus 8, and they're going to cancel each other out here, right? But I didn't want to do that, did I? I wanted to rewrite because I told you I would. So I'm going to rewrite the whole thing. X minus 8 equals 7. I'm going to do my math on this one. Why? Because now I know what I started with. And I'm going to add 8 on this side because I don't want my scale to fall out of balance. X equals 15. And I know you knew that from the beginning. But if you can show the steps, keep your equal sign in line, and show a logical progression. When you get to calculus and you're solving an entire equation on one whole big whiteboard because you started like this, that's where it all ends up. So that's the first set. I'll go to the next shortly.